Welcome back. We are discussing the art of ensuring integrity. We have seen different algorithms for maintaining the integrity, that hash algorithms, HMAC algorithms, salting, and digital certificates. We'll try to discuss the another part is database integrity enforcement. In this database integrity enforcement, this database provide an efficient way to store, retrieve, and analyze data. As data collection increases and data becomes more sensitive, it is important for cybersecurity professionals to protect the growing number of database. So think of a database as an electronic filing system. Data integrity refers to the accuracy. So in this, the data integrity as said refers to accuracy, consistency, and the reliability of data stored in the database. So, the responsibility of data integrity falls on database designers, developers, and organizations management. So, there are four data integrity rules or constraints are one is entity integrity, the entity integrity. Another one is domain integrity, referential integrity, where the primary keys and foreign keys are used, and user defined integrity. So we'll see this one by one. In the entity integrity, if you take any entity, all rows must have a unique identifier. If any rows are having double IDs, same IDs, then there is a duplication here. So in this entity integrity, it ensures that all rows must have a unique identifier called a primary key. We call this as your primary key. So another data integrity rule in the database is domain integrity. So in domain integrity, all data stored in a column must allow the same format and definition. So in this domain integrity, if you take this column, okay, data type column, it must follow same data type, that text data type. So it ensures that the same format and definition should be used in every column. In entity integrity, there should be a primary key that every row must have the same, the unique key. In domain integrity, the column should have the same format. Third one is referential integrity. So in the referential integrity, table relationships must remain consistent. For a single entity, for a single user, there may be multiple entities. So table relationship must remain consistent. So therefore, a user cannot delete a record which is related to another one. You can see in this figure. So the product entity and your supplier entity, okay, so they are referential, that they must be related to each other, they remain consistent. If any changes happens in products, those changes must also updates in the suppliers. Another entity is called the user defined entity. So, in this user defined entity, a set of rules defined by a user which does not belong to one of the other categories. So, as you can see, for example, a customer places a new order. In this order entity, you can see in this example. So, when a customer places a new order, the user first checks to see if this is a new customer. If it is, the user adds the new customer to a customer table or not. So, for that, it provides the customer type, email ID, and salesperson name. And if it is new customer, then the new entity will be created here. This is your user defined entity. So then, what is the data entry control in the database? Then, for database integrity, we'll try to discuss that data entry control. So, data entry involves inputting data to a system. A set of controls ensures that users enter the correct data. So, in the drop down master data control, suppose have a drop down option for master tables instead of asking individuals to enter the data. An example of drop down master data control is using the locations list from the US postal address. In this example, when creating the account, and to standardize it. So, in the data field validation control, uh, the setup rules for basic checking includes. Let us see the data field validation one. One is the mandatory input ensures that a required field contains data. So that is, in a row, it must have a primary key that must be unique, and in column, in domain integrity, the column must have the same format for all the rows. That is the mandatory input that ensures that a required field contains data. It will not allow any null data. And input masks prevent the users from entering invalid data or help ensure that they enter data consistency, like a phone number, for example. And the in the data field validation control, the positive dollar amount is another set of rule for basic checks, including, and the data ranges ensures that a user enters data within a given range only, like your date of birth enters like 01181820, for example. And the mandatory second person approval, that is, a bank teller receives a deposit or withdraw request greater than a specified value, triggers a second or third approval. And maximum record modification triggers. That means the number of records modified exceeds a predetermined number within a specific period of time, that blocks a user until a manager identifies whether or not the transactions were legitimate. And unusual activity trigger, a system locks when it recognizes unusual activities. So these are the data entry controls. Then for data validation rules, we'll see the validation rules. A validation rule checks that data falls within the parameters defined by the database designer. A validation rule helps to ensure the completeness, accuracy, and consistency of data. So the criteria used in validation rule, which includes the following, is size, that checks the number of characters in a data item, and the format, that checks the that the data conforms to a specific format, text format or integer format or floating format, so different data types. And consistency, that checks for the consistency of code in related data items in two different entities. And range, that checks that data lies within a minimum and maximum value. And finally, check digit is used. Check digit provides for an extra calculation to generate a check digit for error detection. So in this example, you can see here the first for ISBN, the calculating the check digit for a 10 digit ISBN. So how it happens? So in this, to check this digit, you can find the multiple the ISBN number is 158714373. Then you need to add this check digit to this format for validation rule. So here you can multiply the first digit of the ISBN by 10, the second digit by 9, because it's having 10 digit ISBN number, total 10 digits. So the first one is 10th digit, the ninth digit, 8th digit, 7th digit, 6th digit, and so on. So you multiply the first digit, 1 with 10, then 5 with 9, 8 with 8, 7 with 7, 1 with 1, 6, 4 with 5, 3 with 4, 7 with 3, and 3 with your 2. So then add up all these results, that will give you the result that 233 by adding of all this. So in this validation rule of check digit. So then third step, the check digit is the number which is needed to get the total to add to a multiple of 11. Multiple of 11. So for that, by adding 9 to this 233, which is equal to 242, which is a multiple of your 11. So here, in each step in this figure, to see the result of check digit calculation. So these are the rules. So this is the validation rules. Now let us see the data type validation. So in the data type validation, as you said in the columns, the data type validation is the simplest data validation and verifies that a user entering data is consistent with the type of characters expected. For example, a phone number would not contain alpha characters. So database allows three data types: integer, string, and decimal data types. Okay. So let us see the input validation of your database. Uh, so in this input validation, one of the most vulnerable aspects of database integrity management is controlling the data input process. So many well-known attacks run against database and insert malformed data. So the attack can confuse, crash, or make the application divulge too much information to the attacker. So attackers use automated input attacks. So, for example, users fill out a form via the web, suppose, by using the web application. So, when a user fill out a form via a web application to subscribe to a newsletter, a database application automatically generates and sends email confirmation for validation when it creates. When it submits, then the confirmation will be sent back, email confirmation. So when users receives their email confirmation with a URL link to confirm their subscription, attackers modify the URL link. So these modifications includes changing the username, email addresses, or subscription status. So the email returns back to the server hosting the application. If the web server did not verify that the email address or other account information submitted matched the subscription information, the server received bogus information. So hackers can automate the attack to flood the web application with the thousands of the invalid subscribers to the newsletter database. So this is the input validation. So another is in database validation, the anomaly verification is required. So what is that anomaly verification is required means? The anomaly detection refers to identifying patterns in data that do not conform to expected behavior. So these non-conforming patterns or anomalies are the outliers, exceptions, the aberrations, or surprises in different database applications. So, anomaly detection and verification is an important countermeasure or the safeguard in identifying fraud detection. So, database anomaly detection can identify credit card and the insurance fraud. Database anomaly detection can protect data from massive destruction or changes. Anomaly verification requires verification data requests or modifications when a system detects unusual or surprising patterns. An example of this is a credit card with two transactions in vastly different request locations in a short term, in short duration. So if a transaction request from New York City occurs at 10:30 a.m. and a second request comes from Chicago at 10:35 a.m., the system triggers a verification of the second transaction. So a second example, suppose for this anomaly verification, the second example occurs when an unusual number of email address modifications happen in an unusual number of database records. Since email data launch denial of service attack, DOS attack, the email modification of thousands of records could indicate that an attacker is using an organization's database as a tool for his or her denial of service attack. So for database validation, anomaly verification is required, right? So now, uh, next we'll see the entity integration. So to check the entity integration, give me a second, please. Okay. So as I'll back. So the entity integrity, as you said, how to do this entity integrity? You can see in the figure that the database is like a electronic filing system, as we said. So maintaining proper filing is critical in maintaining the trustworthiness and usefulness of the data. So within the usefulness of the data within the database. So tables, in this entity, if you take this entity, you're having the tables. In the table, you are having the records. Each row represents the records. So tables, records, fields, and data within each field make up a database. So, in order to maintain the integrity of the database filing system, users must follow certain rules. So, entity integrity is an integrity rule which states that every table must have a primary key and that the column or columns chosen to be the primary key must be unique and not null. It will not allow any null value. So null in database signifies missing or unknown values. So entity integrity enables proper organization of data for the record as shown in the figure. You can see that for this primary, the id, the port id, okay, it maintains the record and data in this table. That is, this data must be recorded in this row, right? So now see, this is the integrity rule, and there is a referential integrity also. Yeah, this is what we just discussed. So the in the referential integrity, this is another important concept in the database integrity requirement. So this important concept is the relationship between different filing systems or different tables. This is one table, this is another table. So this is this referential integrity is this the concept of the relationship between these two tables. So the basis of referential integrity is the primary key and foreign keys. Primary key and the foreign key. So this is a primary key in table 1, and if the same item is used in ordering in table 2, that becomes the foreign key. So the concept is primary key will not allow any null values. So a foreign key in one table references a primary key, a second table. So the primary key for a table unique identifies entities, that is rows in the table, and referential integrity maintains the integrity of foreign keys. Another one is domain integrity. How the column is going to be integrated, that we see domain integrity. So as you see in this diagram, there are the one column. So domain integrity ensures that all the data items in a column, all the data items in the given column fall within a defined set of valid values. Each column in a table has a defined set of values, such as the set of all numbers for credit card numbers, social security numbers, or email addresses. So, limiting the value assigned to an instance of the column, that is an attribute. So that is, as we said, the limiting the value which is assigned to an instance of that column enforces domain integrity in this case. So domain integrity enforcement can be as simple as choosing the correct data type, length, and an or format for a column. So this is domain integrity. So, the entity integrity, referral integrity, and domain integrity. Now we'll see we also seen the user defined integrity cells. So by understanding this concept, you can complete the lab by using the Wireshark to compare the telnet and SSH traffic. Okay. So, as the art of integrity, if we try to summarize it in this chapter, in this session, we discussed how the art of integrity ensures that data remain unchanged by anyone or anything over its entire life. We also started discussing the types of data integrity controls like hashing algorithms, password salting, and key hash message authentication code, the HMAC, are which are important concepts for the cyber heroes to use in the implementation of digital signatures and certificates. And these tools provide a way for cybersecurity specialists to verify the authenticity of messages and documents. So we also discussed and concluded this chapter with a discussion of database integrity enforcement. So having a well controlled and well defined data integrity system increases the stability, performance, and maintainability of a database system. So, with this, I would like to say thank you. In the next session, we'll try to discuss about the five nines concept for securing the data. Thank you.